All right, hi class, this is Mr. Clancy. We're continuing the Chapter 5 notes, and again, you can use this video, or if you'd like, you may follow along with the Chapter 5. If you could, would you mind skipping ahead? We actually stopped here at our last, I think we made it up to section 5.3 in the last video. Would you be kind enough to skip up to section 5.6? I want to do some problem solving and dimensional analysis. Kind of introduce this to you. At the very end, we'll talk on the last section about density a little bit. And I'll let you see if you can work through some of the other temperature conversion stuff like that. Just do your very best with this. Give me your best effort while I'm gone, and we will go over it next week if you cannot get this, okay? So this is problem solving and dimensional analysis. You had to purchase widgets for the upcoming fundraising. You have come across a good deal. Someone is going to sell them at, how much do 53 widgets cost? Set this problem up in such a way you can click the units cancel. So just like if I have a common factor in the numerator, if I had like, for example, 14, okay, divided by 7, all right, I could say that this is 7 times 2 over 7, all right, and I could cancel out the common 7 in the numerator and denominator, so this becomes 2, so I know my answer is 2. The same principle is true with dimensional analysis, except you're going to cancel out the units. So let's look at this here. We want to know how much 53 unit widgets cost. So I'm going to start with my known, which is 53 widgets. All right. And then I'm going to set this up at, I'm going to set up what's called the conversion factor for this. This is $1.23 for one widget. All right, and as I do this, where the canceling out can take place. If you want, you can put this over 1, since 1 is the identity element. I'll leave that to you. But 53. Basically, by the 123, and I'm going to get $65.19 is my cost. So the units actually cancel out. All right, now we're going to look at another example. On the planet Zorg, the exchange rate for money is $1 equals 67 zigs. You are vacationing on Zorg for 14 days and brought along $575 cash, and you want to exchange this for zigs. What's your equivalent statement? Well, your equivalent statement basically is $1 equals, I'll just put this as, all right, equals 67 zigs. All right, $1 equals 67 zigs. Two conversion factors that I can use, all right, to convert this or actually conversion factors I can adopt, if you will, from the equivalent statement. One would be 67 zigs per $1. All right, and the other, I'm going to put or, I could put $1 for 67 zigs. All right, so either one would be acceptable. Now, which one can I use to convert from dollars to zigs? All right, how many zigs do I get for $575? Well, what I'm going to do is I want to convert 2 zigs, so I'm going to select this conversion factor right here. So basically, in order to convert that, I'm going to take $575. I can put this over 1, all right, and then times this conversion factor right here, which is 67 zigs for $1. All right, if I had dollar up here, the dollars would actually cancel out. I'll just put D for, all right. the dollars actually cancel out as a common unit. And I have a pretty easy problem. I'm just going to do 575 times 67, which leaves me 38,525 zigs. So I use this conversion factor from the above equivalence statement because I'm looking for zigs. So basically, the one I'm looking for, the unit I'm looking for, is going to be in the numerator of the conversion factor. So let's try, let me circle this answer here. Always a good idea to circle it. The planet Zorg has a Taco Bell. Yes, a taste of home. The Mexican pizza with a taco and a drink costs 568.83 zigs. How much is that in dollars? So set it up so that your units cancel. In this case here, I'm going to start with my known, which is 5. Let's see, 5. Whoops. 5. We'll use a dollar sign there. 568.83 zigs. All right. Again, I could put this over 1 if I'd like. All right. And then my conversion factor this time, I'm going to use this one. I'll just say $1 over here for, let's see, for 67 zigs. All right, so basically a zig, the zigs will cancel out. All right, I'm going to take the 568 and multiply it by 1, which is 568.83, I should say. Multiply it by 1, which is 568.83, and divide by 67. So I've got 568.83, and I divide this by 67. Equals $8.49. And the key thing is to see that the zigs cancel out as shown. All right. Now, let's look at the next one. There are 2 iGals in 1 odunku and 6 odunku in 4 Folgers. If you have 3 iGals, how many Folgers do you have? All right, so I'm going to start with my, let's say I'm going to start with 3 iGals. All right, so I'm going to say 3 iGals. Oops, that's an I. All right. My first conversion factor, I'm going to set up iGals down here for 1 odunku. All right, so 1 odunku is equivalent to 2 iGals. All right, then my second conversion factor, I'm actually going to use the second one here because I want to convert, if you follow this thinking. So down here, the odunku is going to go down here. I'm going to have 6 odunkus. All right, for 4 Folgers. This takes a little practice to get used to these, but once you do a few, these are pretty straightforward. Again, I'm going to put this over 1 that helps me with my identity. So base, or 1 is the identity element, just kind of helps me set it up. Because I'm going to, the iGals will cancel out. The odunkus will cancel out. Remember, these are common factor. Folgers, which is exactly what the problem called for. And let's see, I've got, this is going to be 3 times 1, which is 3 times 4, which is 12. Okay, I'm going to multiply across here, divided or multiplied by, or divided by this product, if you will, 1 times 2 times 6, which is also 12. So this answer is 1 Folger. So a little confusing, but kind of try to wrap your thinking around that as we get used to some dimensional analysis. All right. All right. Let's try a couple here. I'm going to set you up with something here. Then we're going to get over to some density work. All right. 1 inch is equal to 2.54 centimeters. This is cm. All right. What are 2 equivalent statements from this conversion factor? So basically I can take 1 inch is equal to 2.54 cm, or 2.54 cm equals 1 inch. All right, how many centimeters are in 22.1 inches? So we're going to take 22 inches, put this over 1. My conversion factor, since I'm looking for centimeters, I'm going to pick this one right here because I want centimeters on top. This is going to be 2.54 cm divided by 1 inch. All right, the inches cancel out, as we've talked about. My answer would be 22.1 times, which gives me 56.134 centimeters. That is basically the essence of conversion analysis. So, let's see, how many feet are in 1 kilometer? And how many kilometers are in 954.546 millimeters? All right. I'm going to let you try this one here. So you try this on your own at your table. See if you can figure that out with it. There are your conversion factors there. Always start with your known. Your known here is 1 kilometer. I'm going to show you how to set this particular one up. This is a little harder, because you'll want to switch back to the main unit, which is meters. All right. What I would set this up as 953.546 millimeters. All right. Millimeters. Again, I'm going to put this over 1. I'm going to set up 2 conversion factors to do this. The first one, I'm going to convert this millimeters back to meters. So I'm going to say 1 meter has 1,000 millimeters. Remember, I said milli, centi, and kilo. You must know there are 1,000 millimeters in one meter. Now I'm going to come down here. This is going to be meters down here, because I want it to cancel out. So I'm going to say 1,000 meters in 1 kilometer. All right. So if I do this, notice the meters cancels out, the millimeters cancel out. What left is kilometers, which is exactly what the problem called for. And now I've got 9.
Reminder for you that it is now 4:45. On Wednesdays, we have a commitment to Willow Creek to make sure that we are all students, faculty, and staff out of the main academic building and the Fine Arts Center by 5 p.m. Please help us by finishing up your work or practices quickly so you are able to be out of the building by 5 p.m. In case of inclement weather, you are welcome to wait for rides.
All right, hang on.
In the Field House Link area. Have a great evening.
All right, so now what I'm going to have is 953.546 divided by, or times 1 times 1. So these are all stay the same. So this is going to be 953.546 divided by 1,000, and this is going to give me 0.953.546 kilometers. All right. So give this one a try as well. All right. Now I'm out of time this afternoon, but what I'd like you to do, I want you to try these 2. Then I want you to go to the last section if you can. All right, I want you to go to the last section. Okay? And based on what we did, listen carefully, I want you to try this to the best of your ability, the density section. Remember, this is interactive. Remember, we talked about D. We did our triangle in our lab. I want you to do a good job on this for me, okay? D, M, and V. All right? Do your best on this. See if you can come up with the answer to these problems here, and then we'll talk about it next week. Thank you so much. Bye-bye.